In this final screencast for Chapter 10, we discussed the idea of invertibility. You have seen that linear and exponential functions have inverses, but most functions do not. Those functions that do have inverse functions are called invertible. The function that's used in the next example is an example of a non-invertible function. In example 10.10, we consider the function y equals u of x equals x squared. In part A, we begin by completing an input-output table for this function. So we have in our first column several different input values, and in our second column we're going to give the corresponding outputs. If I substitute -3 into this function, -3 gets squared, and the output is 9. If I substitute -2 into the function, I arrive at an output of 4. Similarly, I get a 1, a 0, a 1, a 4, and a 9. So let's go ahead and look at part B. Use this table to construct an input-output table for a potential inverse function, and then we'll look to see what goes wrong. So let's make a table of values for what would be an inverse function. I'm going to orient my table this direction this time just to save some space. So recall that inverse functions have opposite inputs and outputs. So if these values are inputs for the u function and these are the outputs for the u function, that would suggest these are inputs for the inverse and these are outputs for the inverse. So in particular, if I substitute the number 9 in according to my table, I should get -3 out. If I substitute 4 in, I should get -2 out. If I put 1 in, I get -1 out. If I put 0 in, I get 0 out. If I put 1 in, I get 1 out. If I put 4 in, I get 2 out. If I put 9 in, I get 3 out. But of course, there's a problem here. Notice that when I put in the number 9, I get 2 different outputs from the same input. This problem occurs again and again. If I put the number 4 into this function, I get 2 different outputs. Similarly, if I put the number 1 in, again I arrive at 2 different outputs. For almost every number we put into this potential inverse function, we get 2 outputs. This suggests that our potential inverse function can't really be a function at all. Recall that every function has a very specific condition that it satisfies, namely that every input has at most one output. So if you have an equation where you put in an input and you get more than one output, that means that that process isn't a function. So that's what goes wrong in this particular case. Our potential inverse isn't a function. So I'll summarize that. So the potential inverse is not a function. Let's look at the situation from a graphical perspective. So let's sketch the graphs of both of these functions. You can see I've already got the diagonal drawn in. So I'm going to begin by drawing a graph of this function u. When the input is -3, the output was 9. If I put -2 in, the output was 4. If I put -1 in, the output is 1. Then we got 0, 0, and 1. When I put in 2, I get 4 out. If I put 3 in, I get 9 out. So you can see the basic trend. Similarly, I can draw a picture of the proposed inverse. If I substitute 9 into the potential inverse, I get a -3. If I substitute 4 in, I get a -2. If I substitute 1 in, I get a -1. If I substitute 0 in, I get a 0. If I substitute 1 in, I can get a 1. If I substitute 4 in, I can get a 2. And if I substitute 9 in, I can get a 3. And if I draw this curve, it looks like this. And so you can see what's going wrong here. Notice that for the value of 9, there are 2 outputs. For the value of 4, for example, there are 2 outputs. No matter what input I pick, no matter what x value I pick, notice there will always be 2 outputs for every input. And once again, this implies that the potential inverse is not a function. Linear and exponential functions have a feature in common, that functions like u of x equals x squared, that's the function in our last example, that these functions don't share, namely that they are always either strictly increasing or strictly decreasing. The graph of the function u of x equals x squared, notice that it begins by decreasing and then it starts increasing. Functions that are strictly increasing or strictly decreasing are the ones that are invertible. In other words, those are the functions that have inverse functions.